let's start looking at the questions. Number 2. So to measure the volume of pebble, so you see before you measure anything, this reading here, what is it? Let me make it larger for you. This is 50, 60, 70. Okay, let's see. Where is the 100? The 100 is this level. 150 is over here, and then the 50 is over here. Okay, so we are looking at this number here, which is, this is 50, 60, 70, 80. So this is 80 cm cube without anything put in. All right. Then later when I put a pebble, it becomes this level. So 100 is over here. This is 100. This will be 110, 120. So this will be 100 120 cm cube. So what are they asking for? They're asking for the volume before and after. So it's 80, 120. That's how you do this question. So you can put A, you can put C. You're going to be considered correct. Okay. So this one not difficult. Let's move on. With reference to question 2, which is this question again. The density is 2.5 grams per cm cube. Okay, this is where we start to understand what density means. I've been teaching you last week. Learn how to break this sentence up like this and tell yourself the meaning of this density is saying that every 1 cm cube is 2.5 grams. Okay, that's what this is saying. And what is the volume of the pebble? You see, the pebble, the difference, right? The difference is 40 cm cube. This is the volume of the pebble. So if you know the volume of the pebble is 40, are you able to find out what is this unknown number? You can do basic mathematics, right? If 1 cm cube is 2.5, then 40 will be 40 times 2.5. And that will give you the answer to be 100. Understand how to do this? Okay, so like I said, you don't need a formula. But if you want the formula, if you say, Mr. Ang, can I use the formula to do? You can. What is the formula I teach you? Density is mass over volume. Now from here, you can convert this into the triangle that all of us have learned before in primary school. This is what it will look like. This is how you convert this into this. So if the question is asking for mass, what do you need to do? You need to take the density times the volume, which is to take 2.5 times 40, and you're still going to get the same answer. But using formula, suddenly you're not thinking about what's going on anymore. I don't like that. I like you to think about what's going on. For example, 1 cm cube is this much. And later when you're interested in 40, I'm sure you can find out what this will be, right? I prefer it this way, okay? I give you time, copy what you need. I pause the recording here first. Number 4, Kyung-Yi wanted to transfer the remaining milk in the carton into a smaller container so that less space is taken up in the fridge. What information will help her find out the right container? I don't quite understand what you really want, but let me interpret this again. So to me, it seems like the carton is too big to be put in the fridge. Maybe because of the size, maybe because of the height, and so on. But would you agree that whatever volume you have here, even after you transfer to the smaller okay, I think I know what it's talking about. So let's say you have a milk, okay, you have a milk. It is still, they are left over, but this entire container is too big to be put in the fridge. So she wants to use another container. So we are hoping that the container is this size so that she can fill in, so that she can pour all the remaining milk inside. You understand what they're talking about now? Okay, so this is what, so basically what information to find the right container. It looks to me the answer is I need to know the volume, the size. What is the answer they gave behind? Can you check for me? What is the answer they give, guys? C. So remember last week I mentioned about the word volume. There are two ways to understand volume: size and space. I think Chloe gave the answer, right? I think Chloe was one of them. So we want to know the size. If you know the size, we know the volume. Or we want to know the space as well. They mean the same thing. Okay. Okay. Question number 5. Who got this correct? Lift up the hands. You got it correct. You guessed it or you know it? Guess. Okay. You? Sorry? You know it. Number 5, you got it right. Is guess or no? Guess. Okay. This is important. Sometimes we get it right. It's because you know ABCD, we just choose one, right? But I want to know who really knows. So Ziyong, you understand, is it? You're right, you're right. Don't need to say. I know what you're talking about. You're on the right track. But let me explain this to the students here. Guys, without using the mathematics which is describing, let me use what I've taught you to understand this, okay? Let's understand the word without changing its mass. What did I say is the meaning of mass? The amount of substance, right? The amount of substance. What does it mean when we say the volume is doubled? What does the word volume means? Volume means the space. Remember, I kept talking about the word space and size. If you know that volume refers to space occupied. You want to listen carefully. My explanation here is different from how other schools and how other teachers will do it. It's also different from what he said. He said the mathematics, and every teacher will say the mathematics is complicated. But let's understand drawing, okay? Space occupied, double. So I want you to know, maybe there's such a thing called before and after. Because when you double it, it simply means that you have a bigger size, but before it was a smaller size. Understand the meaning of doubling? You started small, but you doubled it, right? But without changing its mass, that tells me that the amount of things I have inside remains the same. If the mass is because of having 3 particles, I want you to know that the gas is still having 3 particles. Which one is less packed now, before or after? Which one is less packed? Is it obvious to you by looking at the drawing? Afterwards, it was less packed, right? With a bigger space, you have 3 particles. What does density means? What was the first thing I mentioned to you last week? Packing. Remember the packing thing? So would you agree that the density must have decreased in this sense? Because it's less packed, the density must have decreased. So what is the answer here that suggests that it's decreased? There's 2 options here. Either it's halved or either it's reduced. So would you be thinking of half or quarter? Because of the word double, what is the opposite of doubling? You might be considering using the word halved. You understand what I'm saying? Okay, but if you want to know whether is it half or quarter, then the mathematics must come in. So before we talk about the mathematics, let's use diagram to understand what it means to double the volume. It means you got bigger space now. What it means when we say that the mass has not changed. That means if I have 3 particles, later I still have 3 particles. Is this analogy helping you? Okay, good. You can copy this now. I pause the recording first. So let's talk about what Ziyong did, all right? Now you first have to go back to the meaning of density. But this time around, you go back to the formula of density. Okay? So I'm going to write this, one representing before and one representing after. Okay? So I think what Ziyong did is he gave a number 30, and then let's give a number, let's say 15. That is the volume. Later, the mass remains the same, but the volume doubled. Can you see the numbers? Why I kept 30 above the same? Because the mass is kept the same. But the volume, if I give a number called 15, then later I must make it 30 because of the doubling of the volume. Then you do the math. What is 30 over 15? is actually 2. And what is 30 over 30? It's 1. So from here, you can see that it has halved. Using numbers, you can also see that it's halved. Understand? Okay, you can copy this analogy as well. Whenever you're stuck, you don't know what to do, put in some imaginary numbers. Okay, pause the recording. Okay, number 6. The table shows the liquid and the density. Ice cube. So they are telling you ice cube density is 0.92. Was placed in a clear liquid X and Y. In X, the ice cube float. So this is what you're going to do. You're going to draw the ice cube and tell yourself it floats above, it floats in X. Now, what is the density of ice? It is 0.92. Okay, so for it to float, what can you conclude about X density? More or less than 0.92? More or less? More than 0.92. Is this clear? Because it can float. Then, but in liquid Y, it sank. So what you're going to do is you're going to draw liquid Y and then draw the ice cube below. So if you know the density, it's 0.92. What can you conclude about density of Y? It must have been less than 0.92. Understand what I'm doing? So now let's check. They say that X is mercury. X mercury, it must be more than 0.92, which is okay. Y is petrol. Petrol is 0.80. And is 0.80 considered to be less than 0.92? Yes. So actually the answer, oh, is everything, is it? You check everything can work, is it? Okay. Then this is a lousy question. Okay. Can you work for everything? Let me just do a quick check. Maybe, yeah. Maybe there's an error here. Doesn't matter, but you understand how to do this now? Okay, good. Then let's not waste time on this. Let's do a few more, then I want to give you the challenge question. What does this statement means? So I told you to break this into sentence form. It means that 1 cm cube is 2.7 grams. Remember this? So which answer suggests the same meaning? A volume of 1 cm cube is this mass. So answer is B. Understand what I'm doing? Oh, nothing difficult here. Okay. I think that's about it. We will stop here first. I want to start because the rest are all repeated concepts already. I think they're all repeated. Okay, let me just stop here first.